Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving closest prime numbers in range. So the problem is basically saying that we are given two positive integers left and right, and we want to find the minimum difference among the two prime numbers that is in the range of left and right. So if we look at this example, 11 and 13, it only has a difference of 2 and they are both prime numbers, so that is the minimum difference in the range from 10 to 19, so we will return 11 and 13. And if we look at this example, it doesn't have a pair of two prime numbers, so we just return -1 and -1 as said right over here. So now that we have seen some examples, let's get to how we can solve this problem. Before I explain how we can solve this problem, I'll recommend looking up the sieve of Eratosthenes, because that's basically the algorithm that I will be using. So what we will do is we will iterate from 2 to whatever number is the floor square root of the right number. And for each iteration, we will look at every multiple of the number that we are iterating on, and we will turn that number from true to false. And once we have iterated through all the way to the square root of whatever is on the right, for all the numbers that are still true and is also in the range between left and right, we will add it to the primes array. And then in the end, we will just look at whichever two numbers have the smallest difference, and we will add that to the result. And if we don't have two prime numbers, then we will just return -1 and -1. So let's go over this example. So for this example, the right is 19. The floor square root of 19 would be 4. So we will only iterate from 2 to 4. So first we look at all the multiples of 2 and convert all the multiples from true to false. Then we can look at all the multiples of 3 and then convert all the multiples from true to false. Then we look at the multiples of 4 and convert all the multiples to false if not already done. And now that we have finished iterating from 2 to the floor square root of right, now we just add whatever is true from left to right to primes array. So for this example, we have 11, 13, 17, and 19. So that's what we will add. 11, 13, 17, and 19. And then we will just compare the difference between each other and which ones are the smallest. So the smallest for this example would be 11 and 13 or 17 and 19. But as the problem states, if there are multiple pairs satisfying these conditions, return the one with the smallest value. So we will return 11 and 13, and that would be our result. So the time complexity of this problem would be r log of r plus right minus left. So r would be the number on the right and left would be the number on the left. So the r log r comes from the sieve of Eratosthenes up here, and the right minus left comes from this part where we need to calculate the smallest difference. And the space complexity is O of r, where r is equal to the number on the right, because this array right here can take up to r space. So now let's get to the coding part. So first, we can define a function that will get all the prime numbers. So we'll call it get primes. And we want to set the array to true times right plus 1. We'll set everything to true at first, except the first element, which is 0, will set to false, and number 1 we will set to false because these numbers are not prime. And now we will loop through from 2 to the square root of right plus 1. So for n in range 1 to the n of square root of right plus 1. You can also use 2 instead of 1, but for some reason I just put 1 over here. If not, prime n, continue. And for m in range n plus n, so we're looking at all the multiples of n, and then right plus 1 we will increment by n, and prime m is false. We will set all the multiples to false. After we have done that, we will set up the primes array. This is plural. For I in range length of prime, the previous array, if it is prime, so if prime I, and if the index is greater than the left array, then we will add it to the primes array, append I, and then we can return primes. So now we have defined that function. We'll use that function to get all the prime numbers, and then we will initialize the result as -1 and -1. And the difference initially, we'll call it flow of infinity. So now we will look for the smallest difference. So for I in range 1 to length of primes, if the difference is less than difference, then primes are I minus 1. If it's less than the difference that we originally have, then we will need to reset the difference. to that. And then we will also reset the result. So result is equal to primes of I minus 1 and primes of I. And then we can return result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.